Tech Pneumatics plant simulation is used in all production industries worldwide. Core is the automotive industry and the strategic planning of new production facilities, for example, for new electric car manufacturing. The range goes from high bay warehouses or electro production, like here at Electrolux, up to the high-tech and electronic industry, for example, for solar production lines. The goal is always to increase the production and logistic efficiency and to find production problems virtually before they take place in the real world and create a lot of delays and costs. A plant simulation model is built graphically based on standard building blocks which are managed in a library. You can create your own libraries with your own building blocks, or you can use our standard building blocks. Here we insert a source, a drain, and 3 machines. Those machines are connected with conveyors. They connect automatically to the machines. And that's all we need to start our first simulation model. So very fast, very simple, very intuitive. The simulation speed, if you go to fast forward, is much faster than reality. So here we've already simulated some 100 days of production life, and we are looking at the statistics like the daily throughput or the throughput per hour. Now, if you like to integrate, for example, a quality check, we insert an additional line where we take out, for example, 20% of our material to go for a quality check. We insert the quality station, connect this line again, and this creates a circle which is difficult to be calculated in Excel, but very simple in the simulation, and we see immediately how it works. This station gets an exit control. The exit control defines the percentage. For example, here we choose 80% will not be checked and 20% go to the quality check. The nice thing is that this does not require any compilation, so it can be done directly here in the system. And immediately we see that 20% of the parts are going from the station in the middle to the upper station where the quality check is done, and then go back to the system. Now this creates an additional workload at the central station, and we see that there is an throughput which is reduced. If we look at our throughput numbers in the drain, you can visualize all the results in a chart. So we just drag this conveyor here, the front conveyor, on top of the chart, and we see that this conveyor has a maximum utilization of about 8 parts, and it's used for all the time with the complete number. At the beginning it's empty, and then the conveyor fills up and we have more and more parts in the conveyor. So you can analyze complex production systems. In reality, you build bigger models with hundreds of products or millions of product variants. You can change the process times directly in the resources, so in the machines, or you import them, for example, from SAP. To make the model more realistic, we introduce failures, and now that's something which is also difficult to be calculated and easy to be simulated. So in the class object, we change the availability for all objects altogether to 95%, and this has an impact to the throughput as well. Nice thing is this inheritance that enables us to do the change only once in one object in a library, and it is inherited to all the objects in the simulation model that are already built. For the analysis of the model, there's a graphical tool, the bottleneck analyzer, and it shows the statistics. It shows in green the utilization, yellow blocking times, and red the failures. And we see that the failures are used in all the stations. And in the first machine, we have a backlog, so we have a blocking, and that means that there is a potential for optimization in this model. Now, when we want to see what the impact, for example, of work in progress is, we can use a tool like the Experiment Manager. The Experiment Manager enables us to make changes in the simulation model automatically. For example, here we choose for the conveyor a conveyor capacity between 1 and 8. Now we want to see if we have less material in there, we reduce the capacity, what would be the impact for the output of our complete production. Experiment manager is set. We reset and start the simulation. So we create many simulation runs. Each one reflects one day of real production time, and as a result we get the real numbers for this calculation, and we see in the analysis the minimum, the maximum, the average value when we are changing the capacity of this conveyor. So there is a direct impact from 1 to 2 to 3 parts. The more part we allow in this conveyor, the better, but it's not a linear function, so if you have only 6 or 7 parts, that would be enough. Summary: Tecnomatix Plant Simulation is the tool for modeling, simulation, analysis, visualization and optimization of complex productions and logistics.